Hi guys, I'm just going to talk to you about Sankey diagrams. I know you've probably done this before, I hope, but I just want to review it and basically go through any topics that you haven't really covered since year 9. Obviously that's been a while ago. So first of all, Sankey diagrams, undoubtedly named after somebody. I'm not sure, but probably somebody Sankey. I apologise for how shaky this video is going to be. It's because I haven't actually got my tripod with me, so I'm having to hold it with my hand. So sorry in advance about that. So Sankey diagrams are basically diagrams that show you like the transfer of energy in certain, let's say, certain appliances, etc., etc. So the most obvious one that I always like to talk about is the light bulb. So I'm going to have my input energy is going to be electrical. So that's right, electrical. And sorry, that's the cat meowing in the background. And the rules are, whatever I draw directly out to the right is going to be my useful output energy, and whatever I draw down is going to be my wasted output energy. So what do I want a light bulb for? I want it to light up the room. So my useful energy, this is an arrow here, is going to be, actually I'm going to make that a bit bigger, it's going to be light. I want that to be fairly big. There we go. So I'm going to put light here. And my wasted is going to come down. And what's my wasted energy? And when we're talking about light bulbs, it's going to be thermal, also called heat. So I'm just going to draw that down here. Just going to move that so I can write. I'm going to put heat just because it's smaller. Okay, and that's the general the general rules for drawing a Sankey diagram. Now what is worth mentioning is it doesn't matter how long these two arrows are. Okay, that does not matter. Doesn't even matter how long this section is here. What does matter is the thickness or the width of my arrows. If this was if I had 100 joules of electrical energy, then I need, let's say it's 70 joules light, 30 joules heat. Then if this was 10 squares thick, this would need to be 7 and this would need to be 3. I can't suddenly have produced more energy because of the law of conservation of energy. Energy cannot be created or destroyed, it can only be transferred from one type to another. So it can't be created, so I need the same amount, total amount of like thickness here as I would over here. So I hope that makes sense. Now what they could do is they could get you to finish off the diagram. They could say, you know, what would this be? And you would need, if it would tell you it's talking about a light bulb, so you would know that the useful is going to be light. Or they could do the opposite here. They could ask you what the wasted is and it's going to be heat. You know that. They could remove the total amount of input energy and ask you to calculate that. Well, you know it's just going to be 70 plus 30, so that's 100. They could rub out this one instead and it would say 100 here, and so on. So that's very, very easy. The only other thing they can do is ask you about efficiency. Now, you basically using a Sankey diagram. So the efficiency, I'm going to write it over here as a reminder, is useful output energy, I don't really have space for energy, so I'm not going to, over total input. So in this case, the efficiency of this light bulb that I've just made up is going to be, what's my useful output? That was 70 joules. So 70 over how much have I put in total? 100. What's 70 over 100? That is 70% or 0.7. Okay, now it doesn't matter which one you put. You can either put it as a percentage or as a decimal. This is really important. You can't put it as a fraction, but you can put it as a decimal, percentage or a decimal, unless they state which one they want. If they say give your answer as a percentage, then obviously you have to give it as a percentage, or if they say give it as a decimal, you have to give it as a decimal. Okay, that's nice and easy. Remember, I've got useful output energy over total input energy, but that can also be useful output power in watts divided by total input power in watts. So just remember that.